Guys, welcome back to Rocket Gyan, my fellow space tubers. Today we are again here to witness Rocket Labs open up their launch campaign for 2021 with their mission. Another one leaves the crust. Initially, this mission was scrubbed due to some sensor reading which was out of scope, but now they have figured it out and everything is good, and we are go for launch. Hopefully, the weather cooperates and we can get it to see, like, as in how this rocket lifts up and we can see this Electron rocket up into the sky. So if you don't know Rocket Lab is a rocket company which is very famous for launching small satellites into space, and those small satellites, that's what its market is. And yeah, the Rocket Lab is headed by Peter Beck, and they are also planning to recover the first stage booster. Everything is going on in full swing with that. They also did a mission named as Return to Sender in December 2020, in which they tried to recover their first stage booster and they were very successful. And Peter Beck said that there was very less wear and tear, which means they could reuse that booster, that test booster, also in the next flight. But they won't be using it, but he said that the booster is usable. So yeah, so they have these many places where they are located, although they will be purchasing some two more launch sites in South America. And in future we can see 3 Rocket Lab launches simultaneously going into space. I mean, that would be so awesome. So now we can have a look at the Electron rocket itself. Hi Dave, hi Iron the Space Explorer, hi Ufer Gaming, hi, it's home time. And yeah, so now we can have a look at the Electron rocket. So this is the Electron rocket. It's a two-stage rocket, and height is around 18 meters. It's not a very big rocket. So yeah, as you can see, the maximum payload is also 300 kg and nominal payload is 200 kg. So 300 kg means it's must be in low Earth orbit, and 200 kg means into sun synchronous polar orbit. So yeah, that is the thing. And payload adapter, nothing astonishing about it. So yeah, the kick stage, so they will be using today the kick stage, and this kick stage means that it will be inserted inside the fairing, which means you can see this payload adapter, right? Rather than this payload adapter, this kick stage will be placed here, and above it the satellite will be placed. So why this kick stage is used in some of the launches of the Rocket Lab, it is because they sometimes the customer wants extra delta V for their satellite, and this thing can provide extra delta V by acting as a third stage. But the condition should be that the payload mass should be less than 200 kg or 300 kg, sorry, 200 kg for today. Yeah, payload mass should be very less than 200 kg, because the maximum it can carry is 200 kg, and now it also has to carry this kick stage. So total kick stage plus payload should be around 200. So that's what it is. Okay, and this kick stage is powered by one Curie engine, and yeah, Curie engine is capable of 120 Newton of thrust and is capable of multiple burns during its execution. Then there we have this second stage. So this second stage is known as Rutherford engine, vacuum optimized Rutherford engine. Produces 22 kilonewtons of thrust, runs on RP1 and locks as its fuel, and ISP is 333 seconds. Oh, 333 seconds. Okay. So yeah, made out of carbon composite materials, which simply means that it is very lighter weight. And yeah, then the avionics, nothing but flight computer. And yes, the first stage, so the first stage is powered by 9 Rutherford engines, as you can see here. Here the 9 Rutherford engines are there, and you can also see the engine design is pretty simple for this rocket. I mean, it is not very complex as we see in other rockets, because, and the reason being, the electric turbopumps it uses, because every control of the engine can be controlled by the motor itself using the software. So it does not require any valves or any physical thing which needs to be there, which can make the engine complex. So yes, that's the thing. So um, that's why their engine is pretty nice looking to see. And here it has a ISP of 33303 second, peak thrust of 192 kilonewtons, liftoff of 162 kilonewtons, and it also runs on RP1 and locks as its fuel. And they print 3D, they use 3D printing for their engines. To make their engine, they use 3D printing. I mean, since their engine is pretty simple in design, so that's why they can rely on 3D printing to make their engine. So that's increases their turnaround time. Okay. Now we can have a look at the mission profile. So here we have the mission profile. The orbit which it is going, it is a polar orbit, and the satellite it is carrying is from the OHB group, and the inclination with the Earth's equator will be 90 degrees, since the polar orbit is around 90-degree only. Okay, and yeah, we can also see, we don't know much about the satellite itself, because nothing has been share with public. But we know that the satellite which will be going into the space today is a single communication microsatellite that will open up usage of specific frequencies to support future services from orbit. So it will act as a relay satellite, you can say. And OHB Group is European space technology company, and yeah, it is like that only. So yeah, that's all we know. It is from OHB Group, and it is a single telecommunication satellite. So yes, so this is the mission profile. There will be a liftoff. T minus 2 seconds. There the engines will ignite, and t equal to 0 second, the liftoff will happen. And t plus 230, the MECO will happen, and then the followed by stage separation, followed by this second engine ignition, and the first stage will just simply coast towards the ocean and just crash down there. They don't have any recovery plans for today. And then the fairing will separate. Fairing will also just go and crash into the ocean without any with it. Then the orbit will reach, and battery jet is first of all, the battery jettison will occur. So as you can see here, there's something called battery hot swap, right? So why is it needed? As you already know, this is being fed by electric turbopump engines, right? The engines are fed by electric turbopump engines. That means it uses electricity, it uses battery power. So it has two battery packs, and when one of them is fully depleted, it just jettison it, so as to uh, save some of the mass. And yeah, you can say that's why it increases its overall delta V. So yeah, then after that, electron reaches orbit, and the kick stage is separated from the second stage, and then the kick stage ignites for one time. And yeah, kick stage right now is just igniting for one time, and then the payload will be deployed. Right now we don't know whether the we have any confirmation of Curie being re-entering into the atmosphere, because yeah, we don't have the confirmation yet, but mostly and usually it does re-enter the atmosphere. And yeah, so this is the thing, the rocket, I mean to say. And yeah, so now we can have a look at the I think are they live? Yeah, they are live, so we can switch over to that. Okay, so they do have a good animation going on here. Yep. So this animation has been changed. You can see that usually, previously I should say, it used to have that some carbon fiber raw material kind of a thing as its background, but right now it's pretty plain. So let's just see what happens with today's launch. I'm really excited for this, and yeah, I'm excited for every rocket launch that happens. So forget about me, and yeah, let's just see what happens. So if you have any questions, you can surely ask me, and I'll try to answer them. Uh, KSP simulation is there. Don't worry, it will happen when the time is all right. Okay. So Rocket Lab will be yes, opening their launch campaign with this 2020 another One Leaves the Crust launch. See, Rocket Lab is very famous for naming their missions like so their namings are so good. Another One Leaves the Crust. Wow, it's so accurate for a rocket launch. Okay, no worries. Just see the time and then you can count down time. Then you can uh, accordingly manage in the SpaceX. Okay, and here we go. Do have the same intro, but
Hello and Happy New Year! Welcome to the live broadcast of Rocket Lab's first mission for 2021, a dedicated launch for OHB Group. Today's mission will be Rocket Lab's 18th Electron launch, which is why we've affectionately named this mission Another One Leaves the Crust. I'm Ariana Ryan, a quality engineer in the propulsion team.
And I'm Uriel Baker, the Senior Communications Advisor here at Rocket Lab, and it's great to be joining you from our Mission Control Centre here in Auckland, New Zealand. Right now on your screen you can see Electron vertical on the pad at Rocket Lab Launch Complex 1 on New Zealand's Māhia Peninsula as it awaits its scheduled liftoff time of 7:58 p.m. New Zealand time. The launch crew has been on site and hard at work since early this morning to prepare Electron for launch, carrying out a series of horizontal checks on the pad before Electron was raised vertical at around T-4 hours in preparation for fueling with liquid oxygen and kerosene. Before that begins, Electron weighs around only 1,300 kilograms thanks to its lightweight carbon composite structure. But once it's fully fueled, Electron's liftoff mass is closer to 13 tons. With propellant loading complete for today's mission, it's almost time to go to space. We're at about 12 minutes away from liftoff, which is scheduled to hit it very soon, and all of Electron systems are healthy and operational. However, we're keeping a close eye on the wind levels at the pad, which could see us go into a hold to wait for a better gap in the weather to shoot for.
Okay. So yes, we can see the Electron on the pad, and I'm very surprised that it's 7:58 p.m. there and it's not night there yet. I mean, wow. So that's a thing which I'll take care of from the next stream. But yes, hi Labrat, how are you? We can right now see the Electron sitting on the launch pad.
LDV-con.
And confirm VMS system is ready for clock reset.
Please stand by.
Okay.
Can confirm.
Copy. And currently holding.
Okay. So here we go. And yes, right now we are here, and we will see for sure. We are T minus 12 minutes until the launch, and we do have a hold here. Yes. Okay. Cool. Very cool. And then maybe that's because of the range, not the weather. We'll see. We'll get to know about that in a bit. But yeah.
Okay, so as you can see from the clock on your screen, we have entered a hold at T minus 12 minutes. We'll stick with these gorgeous sunset views of Electron while we wait to hear a new liftoff time.
Exactly. So guys, right now, if you have just joined in, the Electron is currently on hold. We don't know yet what's the reason behind it, but yeah, it is on hold currently. For ground winds. Okay, there you go. Resume shortly. Okay. So till the time we get it back, we can switch over to this. That would be great. Okay, so talking about this week's launch, I mean, we actually had so many launches for this week, that too simultaneously, but every launch was pushed away pushed further because of this weather, some sensor issue or what. So Rocket Labs had a sensor issue, and then they pushed it back towards this time, and now we are here. But there is a Starlink launch also, which was supposed to happen, which didn't happen, which will happen today only. So that's a good sign. uh, After some time, I mean 6 hours or so, the SpaceX Starlink is about to launch, so do join in for that also. I will be like um I should say I don't know whether I'll be having KSP animations with it, but let's see.
Go ahead. Just wanted to let you know of another possible concern here. So our LOX tank temperature, we're unable to get the ullage pressure down, so the temperature is climbing. We are approaching our no-go temperature.
Copy that. Moving to LV.
Okay, so guys, there we have something going on there. So there's some temperature rising. I didn't actually hear it properly, but there was something he was saying that temperature is rising and it is approaching a no-go temperature. So please do something about it. Oh wow, okay, let's see what is there and everything. Let's hope everything is good. Cold is because of the ground winds. And yes, hi Angel, how are you? Let's hope that this vehicle at least is not does not face any problem. Winds weather is manageable but not vehicle. Okay, so let me see if I have any other update regarding this and I'll let you know. Okay, so yes, that was a LOX temperature concern. The temperature which was rising was the LOX temperature, and yes, well, that is not good because of when the LOX temperature rises, the pressure also rises inside the tank. Maybe the pressure can be released with the bleeding valves and those functioning, but then you will have less oxygen to go with, which means some of the fuel will be left unburnt and you won't be able to get into a proper orbit. So yes, that's a pretty good concern there. Let's hope they are able to get it right back. The temperature does not rise significantly now and we can have this Fury lift off. We do have 1 hour and 20 minutes left for the launch window, so okay, so that's a good sign. I mean, yes, something is happening there in the sense the ground support equipments are working right now. Maybe they are trying to fix this issue by depleting the means taking off the detanking the tank, basically LOX tank, and then again filling it with oxygen, because that will make the temperature of this tank to remain at a stable configuration, because the LOX which will be loaded will have a colder temperature than the tank temperature. So maybe, so let's see what happens. They do have some time, so yeah, they can actually check it and maybe have this rocket ready for liftoff. Anamika says, when will it
If you're
lift?
just joining us, as you can see, we're in a hold at T-minus 12 minutes. Those pesky ground level winds are giving us some trouble, but we'll stick with the pad views while we establish a new T0 time.
As she said, yes, they are having some trouble right now, but let's hope they sort this thing out. When the trouble is related to rockets, then it is very unlikely for a launch to happen. Let's see what happens. I am now looking at and having a good look at the any update if I can get, so I can also tell you guys. Not looking some good. Iron, the Space Explorer, you can give your exams, no worries. Just give your exams, and after giving it you can come back. It will take time now because the ground winds are concerned, that's a thing, but now rocket is also having some problems, so yes, they will need some time. So yes, जाओ तुम एग्जाम दे के आओ. Okay. So right now we don't have any as such update, so whenever I'll have any of the update, then I'll update you. So yeah, till then just listen into the music and maybe look at the views on the launch pad. Yes, Angel, that's why we do have some time, so let's hope they figure it out and we can have a good turnaround time. We do have a time for around 1 hour and 10 minutes or so, so yes, the launch window is open till that time. So let's hope they figure it out and we can have the liftoff. But I must not say it, but I am feeling like it won't launch because there is some issue with the rocket. So let's see what happens. Don't know, maybe they will figure it out. Let's see. Right now I think the detanking is going on, that's why this is happening. Maybe, not sure though. till that time, guys, do consider liking this stream. If you want to appreciate my efforts, just like this stream and maybe subscribe if you haven't. You will find many such streams on this channel. And we also have a SpaceX mission coming up today only, so do look out for that. And yeah, you can support me on Patreon. Link is down in the description. It really helps the channel to stay alive. Or super chat is enabled for one-time funding. Really helps. Your super chat is what is enabling this transition of high quality stream to you. So yes, I am trying to improve and improve day by day, so that would not have happened without the support of you also. Yes.
A quick update here from Rocket Lab Mission Control. If you're just joining us for this launch, we are in a hold at T-minus 12 minutes due to the weather. The team are currently working through a new T0 time and will keep you updated throughout the hold.
Man, these sunset views are so awesome to watch. We can literally see the sun setting down. I mean, not exactly the sun, but yeah, the sunshine. We can see that setting down. It was a bit bright before that, and now the dull. So yeah.
Thanks for sticking with us during this hold at T-minus 12 minutes. The team are currently monitoring ground level winds to establish a new T0 time. Bit of a fun fact while we wait, tomorrow is in fact the 3-year anniversary of our first orbital mission, still testing. 3 years later, we're knocking on the door of 100 satellites deployed to orbit. We hope to add to that tally tonight.
Okay, so right now we are again holding in for the winds, and thank you so much Labrat. Thank you so much Labrat for that $7 super chat. Really helps the channel. Thank you so much. I mean, yes, now the effort for this stream is maybe is now, you can say, worth it, because yes, because I actually did the timeline thing before for today's stream. It took very much time, actually, I should say that. So yeah, looking in that hopefully they figure it out. And one thing which I should be saying that is that the maybe during the night we need to be waiting for the sun to set, and during the night the LOX temperature could remain stable, maybe, but that can only happen if they detank it and then again tank it, so that the LOX is at cryogenic temperature. And also that also means that it should not be going to a orbit in which it needs to be on the sunny side of the earth. If it is going to a shady side, then it's okay, but let's see what happens. It is going to a sun synchronous orbit, right? And if it launches during the night, maybe it will have I don't know. Let's see what happens, but yeah. Are we again ticking on? A sec. T-minus 14 minutes. Okay.
As you can see, the clock has been
That is so
restarted
good.
with a new T0 of 0726 UTC, and we are at T-minus 13 minutes and 57 seconds and counting.
That is so good. That means today we will be seeing this launch. I mean, wow, they figure out the LOX temperature concern. That is so cool. So let me just update the time for you guys. Oopsie doopsie.
All stations proceeding with a go-no-go sequence. Looking for your status for launch at this time. Stage.
Stages go.
Avionics.
Avionics is go.
AFTS.
AFTS is go.
GNC.
GNC is go.
VCon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is currently red and tracking at least 50% chance of being red at T0 as discussed.
Copy. Mission management.
Mission management is go.
LD sub.
LD sub go.
Exec.
Exec is go.
Go, no go sequence complete. We're at T-minus 11 minutes, 34 seconds and counting. We're go for terminal count pending wind conditions being favorable at T0. From this time on, the 3-word hold procedure is in effect. GC
Okay.
proceed with pad terminal checks, sequence 44.
GC copies.
Okay, so we are currently going in for the launch, but did I hear it right? Were they saying that there was a problem with the range is red or what? The weather or the range? I didn't get at that time, but
Avionics LD mission.
Go ahead, LD.
Proceed with sequence 45. Avionics terminal checks.
Copy that. Proceeding with avionics terminal checks.
Stage 1 igniter, pressures verified, hydraulic pressures verified, stage 1 pre-valves open. LD GC mission.
Go ahead.
Pad terminal checks complete.
Copy. Stage LD mission.
LD stage.
Proceed with stage channel checks, sequence 46.
Commencing.
I think it is happening. That is for sure, but the ground winds are subject to change and they are waiting at T-minus 0 seconds if they can have a good data at that time. Then they will be
Alright, so there we
launching.
have it. That concludes the poll. The weather is still no go at T0 currently, but hopefully will subside in time for liftoff.
Okay, so that was red. Okay, got it now.
Today's mission will launch a single communications microsatellite, procured for OHB Group through OHB Cosmos International Launch Service. The launch is taking place just 6 months from contract signing, demonstrating the streamlined path to orbit that Electron offers our customers. By flying as a dedicated mission on Electron, OHB has control over launch timing, desired orbit, integration schedule, and a range of other mission parameters. After liftoff, Electron's second stage will deliver the kick stage and payload to an elliptical parking orbit. From there, Electron's kick stage will perform a series of burns with its reliable Curie engine to raise apogee and act as a space tug to deliver OHB payload to its precise orbit. Following payload deployment, the kick stage will perform a deorbit burn to lower its perigee. By dropping closer to the Earth, the kick stage will experience greater atmospheric drag, enabling it to re-enter and burn up faster to avoid becoming space junk.
Now, we won't be showing a live view of payload deployment today, so the webcast will end shortly after the kick stage separates from Electron's second stage at around 9 minutes into the mission. We'll share the news of payload deployment on our social media channels, which is expected to occur at about an hour after liftoff, so keep an eye out there for further updates. Also, a reminder, today's launch is not a recovery mission. We learned a lot from our return to sender mission a few weeks ago that sets us on a strong path to make Electron a reusable launch vehicle. And so this year we will be launching even more recovery missions. The first will be very similar to the return to sender test and will include parachute deployment and splashdown in the ocean to allow our recovery team to validate the successes of our first test with a second set of recovery data. We're excited to be able to tell you more about those upcoming missions very soon.
AFTS is green and enabled for flight.
LD stage mission.
Go ahead.
Stage terminal checks complete.
Copy that.
Okay, so let's hope this weather cooperates and we can have this beauty lift off from the sky, lift off to the sky, sorry. And yes, I'm so excited for this mission. Winds are still no go, but as they say that it is projected to improve. So let's see what happens. I'm so
Another
excited
One
for it.
Leaves The Crust is the first mission in a busy launch manifest for Rocket Lab in 2021. This year we'll be launching multiple dedicated and rideshare small satellite missions for both government and commercial customers. It's also the year we'll be launching to the moon for NASA with our capstone mission, which will see us use Electron and Photon to transport a satellite to lunar orbit in support of the agency's Artemis program.
We also have 2 new pads to debut this year. So we'll see liftoffs from Launch Complex 2 in Virginia, as well as our newest launch pad, LC-1B, located at Launch Complex 1. And of course, as Muriel mentioned before, we'll be continuing our program to make Electron a reusable launch vehicle, with even more recovery missions planned this year. 2021 is going to be a huge year for our team and customers, but before we kick into the first mission of the year, let's take a look at all the incredible things we got up to last year.
Wow, Rocket Lab is actually pushing it towards its limits.
3, 2, 1.
This was a mission which actually was not very successful, but yeah, they figured it out what was the issue and they managed it. I must say that music was kind of dope, yeah.
2020 was a big year for our team, but we can't wait to make 2021 even bigger, starting with today's launch, of course. We're now at T-minus 1 minute and 52 seconds to lift off, although we will continue to monitor those winds all the way up to T0. The internal flight computer will shortly take over the countdown to launch while our operators continue to monitor Electron systems. So let's hand over now to Mission Control to listen in on the operators' calls during the final seconds to liftoff.
Okay, so this is happening, and let's see and let's hope we can have this thing lift off to the sky and beyond. Wow, 2020 was a fully packed year for Rocket Lab, and 2021 is also same because as you just heard that they will be launching from the another
Anti-dodging is disabled.
launch sites and going on with their recovery plans. T-1 minute.
Flow engine purge enabled.
Wow, I think they are going in for the launch.
Stage
Let's
1 and
hope.
Stage 2 tanks are pressed for flight.
I'm so excited. T-minus 40 seconds, guys.
Water deluge enabled.
Yes, they are going in for the launch. T-minus 30 seconds. T-minus 20.
T-minus 20 seconds and counting.
18, 17, 16, 15, 14, 13, 12, 11, 10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3.
Engine start.
And lift off of the Electron.
Stage 1 propulsion is nominal.
Guidance is nominal.
And with that, another one leaves the crust. Electron has
Yes.
successfully cleared the
Enter
pad at
terminal
Launch
detector.
Complex 1 and is on its way to orbit. We're now at 46 seconds into flight of our 18th Electron mission and approaching one of the
H3
first
direct
major
discharge
milestones of any launch, max Q, or maximum aerodynamic pressure. This is the moment during launch when the forces against Electron are at their peak. We'll be coming up to that very shortly, so let's listen in.
Approaching max Q.
Max Q is,
Max Q.
and they have passed Max Q. That is so cool.
And we just heard the call there. Electron has cleared max Q. The stage 1 burn is performing nominally and Electron's trajectory is looking good.
That's what we want. Wow. It is this launch is they are not pitching right away. I mean, they are going up and up and up. Pitching is very less right now.
Nominal. 40 seconds remaining.
AOS Chatham Station.
And there you go. The plumes started expanding, which means we are
Stage 1
approaching
propulsion
space.
is holding nominal.
Shortly, the 9 Rutherford engines on Electron's first stage will shut down. We call this main engine cutoff, or MECO. Right after that, Electron's first and second stages will separate, and the vacuum-optimized 10th Rutherford engine on the second stage will ignite. Let's listen in on calls from Mission Control.
Yes. And here we go, the MECO. Stage sep.
Stage separation.
Second stage ignition. Wow.
You heard the good news there from Mission Control. We've had a successful main engine cutoff, separation of the stages, and ignition of the stage 2
Fairings have
Rutherford engine.
confirmed.
Up next will
Should
be the
be.
fairing jettison.
And
there
there
they
we go.
go. There's clean separation of those halves for the fairing jettison. And one of the reasons for this shiny protective material you might have seen as they tumbled away is to ensure the aerodynamic heating experienced by Electron on ascent doesn't affect the payload on its way to orbit. Electron's second stage is continuing nominally as we approach battery hot swap in the next few minutes, a maneuver unique to the Electron rocket.
My animation actually messed up there. It was kind of funny, but yeah, that's it. That's how it is. So, yep. So right now they are heading in towards the orbit, and now we can see the curvature of the Earth. So yeah, I was right. They were going pretty straight this time, but then now
For
they're
those of
pitching
you
in.
just joining us, we're just about 4 minutes into flight for our first mission of 2021, and Electron is continuing to carry the OHB satellite to its intended destination in a polar orbit. The operations team is tracking no issues, and the burn of the second stage engine is continuing nominally. At the top right hand side of your screen, you can see the live telemetry data we're collecting on Electron's performance currently. Electron has made it cleanly through its early launch milestones and is now approaching one of its next critical operations, the battery hot swap on its second stage. We'll tell you a little bit more about what that involves close to the time it's scheduled to occur at T+6 minutes into the mission.
Yes, now everything is looking good. The altitude, the speed is increasing, everything is going good, and let's hope we get this thing to the orbit.
A quick check-in, and Electron is continuing well on its journey to orbit. We're now at T+5 minutes into the mission, and all of Electron's systems are continuing as they should. The trajectory is still looking nominal for Electron's second stage.
Beginning to throttle down.
Throttle down for battery hot swap.
Stage 2 guidance is holding nominal. 200 seconds remaining.
We're quickly coming up to battery hot swap on Electron's second stage. Our Rutherford engines are fed by electric pumps, which drain the power of the batteries during flight. Once the first set of batteries on stage 2 is depleted, we switch them out and get rid of the old ones we no longer require. The battery hot swap is scheduled to occur just over 6 minutes into the mission, and we're coming up on that very soon. Let's throw you back into mission control to listen in.
And here we go. Battery hot swap. Yeah, there we go.
Battery jettison confirmed.
Hot swap successful.
We've had confirmation that battery hot swap was successful on Electron, and second stage propulsion is continuing nominally. We're just a couple of minutes away now from stage 2 engine shutdown and separation from the kick stage. Electron is currently travelling at speeds of over 16,000 kilometers an hour and at an altitude of more than 300 kilometers.
All is looking good.
For those of you just joining us on our first mission for 2021, another one has indeed left the crust with a successful liftoff. About 2.5 minutes into flight, we had main engine cutoff, stage separation, and stage 2 ignition. We're coming up on separation of the kick stage about T+9 minutes into the mission. You've got an awesome view of the bottom of stage 2 there on your screens. You'll have heard us talk about this being the vacuum optimized version of the Rutherford engine. What this refers to is the larger nozzle bell. Due to the lower pressure at this altitude, the exhaust gases require a longer bell to match the pressure of the environment as they exit, allowing for full thrust utilization.
Okay. So yes, Dave, I'll see what I can do with the craft files. Don't know how to share it, but yeah, let's see. How can I give it to you?
Soon the Rutherford engine on the second stage will throttle down before shutting off completely to allow for clean separation of the stages. We call this SECO, or second engine cutoff, and this separation of the stages will place the kick stage in an elliptical orbit around Earth for a coasting period of around 40 minutes or so. After that, the kick stage's Curie engine will ignite to circularize its orbit around the planet before the payload is deployed.
Guidance is in terminal, 25 seconds remaining.
Orbit reached. Should we reach now? Okay. Oh, okay. There we have it.
Nominal transfer orbit achieved.
And there's the call from Mission Control. The Rutherford engine on the second stage has successfully shut down as planned, and the kick stage has cleanly separated. The kick stage is now travelling around the Earth at a speed of 8 kilometers per second, and what we call a parking orbit. Around 40 minutes from now, the kick stage's 3D printed Curie engine will ignite to position the stage ready for payload deployment. It's thanks to the kick stage's Curie engine that we can provide our customers with pinpoint accuracy for deployment, enabling them to locate and start operating their spacecraft immediately after launch.
Following payload deployment for today's mission, the kick stage will perform a final burn to lower its perigee. That enables it to re-enter the Earth's atmosphere faster and burn up to avoid becoming space junk. As we mentioned before, we won't have video of that or payload deployment, but we'll continue to share updates about this mission on our social media channels, so keep an eye out there. Before we close out today's live broadcast, we'd like to thank our mission partners, OHB Group. We're grateful to have started the year with your team support. And with that, we're going to end today's webcast, so thank you so much for joining us for another Electron mission. We look forward to bringing you many more this year. For the first time in 2021, this is Rocket Lab Mission Control, signing off.
Okay, so yep, here we go, guys. The Electron had successfully lifted off from the pad and headed towards the space, and now the kick stage is orbiting the Earth and will again ignite its Curie engine to circularize the orbit. So, wow, that is so cool. So yes, Dave Sumai says, how does Curie engine look like? Curie engine is a very, I mean, we actually don't know how does it look like, but we know that this Curie engine is very, don't know, I should say that. Rather than saying anything which I don't know, I should say don't know. So yeah, we don't know how does the Curie engine look like, but what we know is that it is a bipropellant or a monopropellant version, which means that is it can be pressure fed, which means only it can use as a RCS thruster. The Curie engine can be used as a RCS thruster. So yes, that's how monopropellant works, right? So yeah. I think we have now actually I made all these animations and all for 1 hour or so, for I mean when the payload would be deployed, but I didn't know that they will end the broadcast with the just going to the orbit. That's why. No, it's not an ion engine. It's not an ion engine. Okay, if I how does it look like? I don't know with this thing. Let me just see if I can get it to you. How does it look like? See, This is how it looks like. There is solar panels behind, and then the engine is there. So yeah. So I think I should be ending the stream now, but do join in for the SpaceX stream, which is which they will be launching the Starlink satellites to the space. I'll be streaming that, so do join in for that. And yeah, thank you so much for tuning in. Really appreciate it. And yeah, until then, this is Priyanshu Rohila. You just saw Rocket Gyan. Stay safe, and Angel says the mission is very successful until now, except by a potential catastrophic fairings happen in KSP. And yeah, that's what KSP is all about, right, Angel? Without explosions, without things going wrong, it's not KSP. So, but the rocket did some uh, stunt, and it managed itself to free itself from the fairing curse. I should say that, yeah. And yeah, so thank you so much for tuning in. Until then, this is Priyanshu Rohila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.